So what we've been doing at the vet school, and you tried a couple of different things, was to move the students into what we're calling critical clinical thinking. And we've done it a couple of different ways. We've had some study. This was really the background for our project, and I think a lot of this is self-evident based upon what Bill has said. But so far, as he said, we're have been using LMSs and things like that to disseminate content. But we use LMSs, or we use, in our school, use ExamSoft for administering digital exams. But mainly, you have to have a right answer or a wrong answer somewhere along the line. But the more complicated and sophisticated assignments that relate to truly complex thinking, like solving a medical problem, really there are many ways to solve that problem, and oftentimes they're all correct. So it has to do with thinking. So our goals here were to use, in this ILSB project, to use the affordances that they've talked about of the advanced information retrieval and the online analysis. Our colleagues from computer sciences are handling that, to develop something that's more scalable, because people that are here at the vet school know one of the biggest things that limits us from putting an essay on an exam is, well, we can't get the things turned around enough with 130 fast enough with 130 students. And even with our exercises, our goal was to have them do, in what we call clinical correlations, an exercise roughly a week or maybe every other week, and be able to give them feedback in a timely way so they can constantly improve. And it's impossible when you don't have a lot of TAs trained up to do it. So we were hoping and this kind of came from using a different system, engaging our computer scientist colleagues to come up with a way to help with the grading. And I think Chase is going to talk about that as well. And then, of course, to keep track of this, which is Bill's just been talking about. And, of course, everything we do, as Bill's pointed out, can be part of research. And that's where we hope to take this. But really, as a teacher, I'm interested in moving our students to a higher level of application. That's really what I want to happen. So to talk about what we did, and it all came in my mind, and I'm just going to tell you a little bit about the background of how I and Megan and a few others, Leslie, we've been here since the beginning of this new curriculum, to notice the blue areas. The blue areas were up between 2009 and 14. The blue areas, the students are in the clinic, so they were in the clinic from the very first day of vet school, and we were responsible for the pink that I just circled. So we were seeing them right after they're in the clinic. And I noted, and I think others noted in the clinic as well, that the students had seen this wonderful experience. It's what they want to be. They viewed clinics, but they really get washed over them. They were confused by it. It was too much. And it got me thinking personally about, well, how can we help them? And I did some reading about critical thinking, and it came to the fact that we shouldn't wait. Traditionally, you wait until the third year, really in the vet school and medical school scenario, you kind of wait until they're in the clinic full time and have all the stuff behind them to start integrating them to how a doctor thinks. But I think it's too late. Now, what we've done now is we've moved the curriculum this way, so that we actually experience that I'm going to show you shortly with our students was in that red area at the top. We just finished it using, in this case, Scholar to try to take the students. So I wanted you to keep that in mind. These students were in the first quarter of their entire veterinary education. And I want to show you some of the things they were able to produce. It's pretty amazing. So this kind of also got me to think about, well, what are we doing with our students? We're spending a lot of time in lecture, and most of the things look like that. I'm sorry, Paul, I think that might have been Paul Hubie. He's here. I think that was your lecture. But I wanted to make it anonymous. I could have picked it from anywhere. As an administrator, I get to see the back of the room. And you can also notice that not all the students are looking at the same thing here. They're all kind of doing their own thing. And that was something that we need to think about in terms of how much we lecture to them. But we have labs, histology, anatomy, and we have discussions. The discussion was our clinical correlations, 2 hours a week, but our tests were an equal amount of time. So the problem with all of this is that what I didn't tell you, these are now all mega courses that are integrated across various topics, but the retention was an issue. We had students that would come, that we'd see right after they moved from a course to a clinical setting in a small group, and the students claim they never had something. Clinicians have told us forever that they never been taught stuff, and we know they have. It's a matter of stickiness, and you need to somehow improve that. So, and initially, clinical correlations was more about, let's lecture at them, this is what a theory of analysis does, or a radiologist does, rather than about this process that we're trying to emphasize now. And we were evaluating more than we were guiding them. So this gets to the issue of, and I kind of talk to Bill now about this, it's about, it needs to be this constant recursive feedback, not, we gave them one time on the test, we have a midterm and a final. When we started these exercises, we gave them one shot, and then we evaluated that. Now, with this, as you'll see, the Scholar, we have an intermediate step, which is draft 1, and then they get peer review, and then draft 2. So we're trying to give them more practice in critical thinking. And why is that important for vet medicine? And I would argue for human medicine, or any practical discipline, professional discipline. Well, first of all, practice, it leads to higher retention. And decision-making is what we do. Most, particularly in veterinary medicine, one of the biggest characteristics that if you were to test the kinds of things we do, you have to have intuitive decision-making. You don't have a full data set all the time. And we have to tell our students this, you're going to make decisions based on odds, you're going to make decisions based on evidence, and you can find it. So the idea of critical clinical thinking and evidence-based medicine, some people say, well, is it the same thing or isn't it? They are related, and we spend a lot of time in our first quarter with our students talking about evidence-based medicine, but we want them to see that in practice. And actually the concept that the Scholar program brings in, the peer review, is absolutely central to how peer-reviewed evidence is published in our profession and most professions. So we got to actually let the students be in that role of reviewer. And I came across this publication called Critical Thinking in Clinical Practice that stated that not teaching clinicians about, this was human docs, and I'd argue it's the same for vet medicine, clinical uncertainty has been referred to as the greatest deficiency of medical education through the 20th century. And as Bill pointed out, we're in the 21st century now. And I'm not sure we fixed it yet. This was a paper in the Journal of Veterinary Medical Education. And to highlight what was done here is they actually went to practitioners and asked them about evidence-based medicine. And most claimed they didn't do it. They didn't use it very much. And our students, when they come in, I ask them whether they've seen evidence-based medicine in an obvious way. And they usually say they don't see it because they have too little time. But they did say they did feel like it was a responsibility of vet schools, of course, to intervene and help develop better skill set, decision-making skills in the students. So that's kind of what the motivation was here. So when you think about clinical decision-making in evidence-based medicine, what we want our students to do, we teach them to do, is to see a problem. And they all want to solve problems. So we try to couch it in a relatively simple case. They always think it's too complicated. But we try to teach them how to break it down. What they need to realize, the questions aren't about giving us a lecture on that particular topic out of a textbook. It's to answer the questions that are important to that case. What's relevant, what's doable, find the best evidence, critically appraise it, and then integrate it to the decision making. And so, this is just to what we did was, as I pointed out, I did this at the end of our first quarter course, and it was in the context at the end of endocrine physiology, but it was also had anatomy, histology that was linked to it, biochemistry. And we gave this as a capstone experience in clinical correlations, which in part was to help them prepare for this, what we call our day 2 exam, which tries to integrate all of the disciplines of histology, neurobiology, physiology, and what am I missing? And what else? Anatomy. And anatomy, of course. Yeah. And so what we did was have 4 cases, and I'm just going to give you a snapshot of these. And they were to do a full analysis, their analysis of one of them. And then after that period of time, roughly about a week, they were then, they put in their first draft. And then they were assigned one of the 3 reviews to do of each of the other 3. So this allowed them to see all 4 cases. They were all published in Scholar ahead of time. And they gave reviews to their colleagues anonymously, and then they were given 4 days to revise these. And we could argue whether that was enough time, but that's the time we had. And then they conducted a self-review. I'm going to show you some data of that. And then just give you an idea, 3 weeks later, we used primarily how they did in their participation in this to determine their credit. But it was 3 weeks after grades were due, and I'm about halfway through, marching through each of them with more detailed comments, and these are some of the data I'll show you. So obviously that's not fast enough for them to get the kind of detailed quality instructor level feedback, and that will get to the issues that we hope that our computer scientists can help us with. So the cases were, this was a dog with diabetes, and there was much more to it, to that, but this is sort of give you a feel for what they were. This is a case of what we call milk fever, hypocalcemia, and this one are puppies that have a pituitary deficiency called dwarfism, and this one had Addison's disease, which is adrenal insufficiency. So they represented the cases, and what I did was lay out questions that were scaffold. We used a different platform where actually these were kind of an outline. But in this case, we just used questions that are in there. I won't show you all of them, but there were some similar things. They were told to try to use the highlights from the case that were actual data from the case and highlight it as a quotation. And I'll tell you that failed miserably. We didn't get them to do that because some of the data were tables. But that we have to think about. There's some value to knowing what they pick as important and relevant, because the beginner tends to pick everything, thinks everything's relevant, whereas the person, as they get more expert, hones in. They see patterns. And so we've been interested, and I think the computer scientists are interested in that. So we asked them to reflect on their learning issues. So this is the reflective part after they go through this. A lot of them, semi-complain, well, I'm not a clinician, how do you make me do all this stuff? And I tell them, endocrine physiology is at least a huge part of endocrine medicine. And then give us references, particularly on those things relating to their learning issues. And then they have at all times, as Bill pointed out, the rubric to know how they're going to be evaluated. And we remind them that the first draft is an individual work, but after the peer review, it becomes a collaborative work in a sense. And then I told them that we would have a review. They always want to know what's going to be on the test and what's the right answer. And I basically more or less refused to give them the right answer, but I highlighted some of their own colleagues' work, which I felt showed a significant amount of accuracy. I got approval from the students to show these. We clapped at the end of the session. And then I also said that I wanted to show some more of the entertaining ones to see which students could use the media most effectively. And so this is the rubric, and our rubric basically was broken down into these parts: problem, list analysis, use of evidence of appropriate literature sources, searching, and then judgment of that quality of that information. Their ability to, this is what I think they're not very good at, obviously, at the beginning, to analyze, put it all together, and then just the basic, have to use the system, have they communicated, put in the reference that they follow directions. And then finally, initially I wasn't even going to include this, but I think a couple of years ago when we started into this, the last one is the only one that asked the question about what they knew, whether they were accurate, with their knowledge and connection. But we want them to connect what they're doing in this case back to what they're learning in the class. So what's normal in this case? First year vet school and medical school is about what's normal. So you obviously can't read that, but each one of these has, more detail for them to look at or the reviewer to look at in that. And then when they go to, they're evaluated on these characteristics from novice to expert. What I'll point out is you start looking at the scores that I'm going to show you next, that are comparing peer-reviewed to self-reviewed to my review. I want you to know that they probably don't have a full concept of this range. And an expert, in my mind, is a specialist in that area. Of course, the student has no real sense of the breadth of knowledge, and I think that may be what makes it a little bit different from Bill's students to our students. Plus, we have a whole bunch of gunners in our class, that think they need to get an A, and they never want to deny somebody else the opportunity to get an A. So this is how they're being judged. I fully expect most of the students to range, depending on what problem and what thing they're doing, the analysis to be mostly in the novice to advanced beginner area, and maybe the depth of their content knowledge to be in that area. Certainly they can get much better at searching the literature and writing something, and following directions. But rarely do I see them in what I feel a proficient to expert. So this is the data analytics dashboard, and I wanted to highlight a couple of things on the it's only on the right side. Okay, I'll point with my hand. So here's the peer review rating, and you can see immediately there's some that stick out. Most of them are pretty high though. These are the average of 3 students, and the length of their analysis and the amount that they edited, which I think is really telling. I mean, these students, are they taking into seriously the reviews that they've gotten and do they make changes? The peer reviews, you can see, are pretty high. I'm sorry, the self-reviews are pretty high, and here's where I was falling on these. And so the only thing I could point out so you'll see that my scores kind of parallel the peer review. Now, my scores are about the final version and not the first draft. We're showing parallel. There's another one low at the bottom, and then there's one that's pretty high. I was ranking, but not as high as the peer. So you can see that there are some parallels at the extremes. But if we look at, and so what I say is I felt, and this was just a qualitative observation, the students took this peer review very seriously. And I think the comments that they provide to their colleagues were very valuable. There was, you can see, significant editing that went on. There were a few that blew it off, but overall I thought the quality of their analyses for this first time around was just amazing. But from the standpoint of trying to use the peer review to replace an expert, this is my score down here, and this is a straight plot against the peer or the self score, where the self score is the red, and so they all love each of themselves. And then the peers are higher and certainly above the identity line there. So, and then I've seen this before. We saw this once before with a smaller set data with a different system, that the students, even at the end of the year, were not as likely to show numerically the scores that I would show. But they do say many of the same comments. They say, well, you know, you didn't have the references in the right way, or you could explain this a little better, or whatever. So I think that's where we have to sort of get to more complex analysis than just these rubrics for. And maybe there's a way to calibrate one to the other. Do you have a question, Mike?
Yeah, just to clarify, so you're saying, Duncan, then that most of the students consider themselves experts in their assessment?
Yeah, that's why I don't think they know. And so, you know, I think the real issue is, are they